Already we have seen what is steady state error and error constants. Position error constant, velocity error constant, and acceleration error constants we have seen. Now let us see generalized error constants. Before seeing generalized error constants, let us review the steady state error for various inputs. Already we have seen three types of inputs. One is step input. Step input, that is R of S equal to 1 by S. Another input is a ramp input. Ramp input, that is R of S equal to 1 upon S square. Next one is parabolic input. Parabolic input. In that case, R of S equal to 1 upon S cube. These are the three types of inputs. Similarly, we have seen three systems we considered. One is type 0 system, means it doesn't have any zero. S power 0 only we have. Tau s plus 1. Tau 2 s plus 1. Like that. So S power 0, that is 1. This is type 0 system. Type 0 system. Type 1 system means you will have S outside. Tau s plus 1. Tau 2 s plus 1. Like that. Here third order system. Type 1 system. Third order type 1 system. This is second order. 1 upon S square, tau 1 S plus 1 and tau 2 S plus 1. Order is 4. Type number is 2. Type 2 system. Order is 4. In this case, order is 4. Order of the system is 4. Here order is 3. Order is 2. Number of S, that is number of poles at origin, says the type number. So here we consider three systems, type 0, type 1, type 2. Order may be anything. Order may be anything. Type 0, type 1, type 2. If for type 0 system, the steady state error is 1 upon 1 plus Kp, where Kp equal to limit S tends to 0 G of S. For type 0 system, type 1 system, whatever may be the system, if input is 1 by S, input is 1 by S, then steady state error is 1 upon 1 plus Kp. If it is velocity error, means steady state error is 1 upon Kv. The acceleration input is 1 upon Ka. Depends upon the input. Acceleration error means the steady state error is one by Ka. But Kp equal to limit S tends to 0 G of S. Kv equal to limit S tends to 0 S G of S. Ka equal to limit S tends to 0 S square G of S. So these are all we have to remember. We should know what is type number. Various input types, 1 upon S step input, 1 upon S square ramp input, 1 upon S cube parabolic input. For step input, the steady state error is 1 by 1 upon 1 plus Kp. For ramp input, 1 upon Kv. For parabolic input, 1 upon Ka. Here, Kp equal to limit S tends to 0 G of S. If it is type 0 system, it is equal to K. If it is type 1 system, this is type 0 system, type 1 system, type 2 system. Type number. K. Kp equal to K. Here, if type 1 system means S will be there. Type 1 system means one S will be in the what is type 1 system means you will get infinity because limit S tends to 0, 1 upon S, something will be there, denominator, numerator. These are all becomes constant, but this S, as it becomes 0, you will get infinity, therefore infinity. For type 2 also, you will have S square in the denominator, that's also infinity. These are all Kp for type 0, type 1, type 2. Similarly, Kv if you take, that is equal to limit S tends to 0, Sg of S. So, Sg of S means type 0 system means in the numerator you will have 0, that's why you will get 0. Here, what you will get K. Here, you will get infinity. Because S square in the denominator, that's why you will get infinity. Ka, acceleration error, constant. Limit S tends to 0, S square G of S. Then what you will get S square, that's why S will be there, that's why 0, 0, here you will get K. So this is the table for error constants. Error constants. This is table for error constants. For error constants, you will get like this. If we substitute here, this K you have to substitute here, steady state error. This is steady state error. 1 upon 1 plus Kp. Kp equal to K. Therefore, 1 by 1 plus K you will get. Steady state error. Here infinity. So 1 by 1 plus infinity, that's why equal to 0. Here also the steady state error constant is infinity. That's why 1 plus infinity, that is equal to 0. Here you are getting 0. The formula is 1 by kV. 1 by kV. If we substitute 0, 1 by 0 equal to infinity. Here you will get 1 by k. Here you will get 1 by infinity equal to 0. Here 1 by 0, that's why infinity. 1 by 0, that's why infinity. That is equal to 1 by k. So this is steady state error table. This is steady state error table. This is error constant table. Here you notice that these three elements are 0. Here these three elements are infinity. Similarly, these three elements are infinity here. Here, error constants, you will get 3 zeros. So here, 1 upon 1 plus k, 1 by k, 1 by k. Here, k, k, k. Here, we can find steady state error if the input is either 1 by s or 1 by s square or 1 by s cube. That's only. Suppose I am having a input r of t equal to 1 means u of t plus 1 by s. Sorry, this is impulse. This is impulse input. 1 by s means step input u of t. 1 by s square means ramp input t u of t. Suppose the input is like this, a combination of ramp, step, and impulse, like that. In that case, you cannot use this. Input is combination of impulse, step, and ramp. In that case, you cannot use this separate derivation. This is, we are having a derivation for step, ramp, and parabolic. We are not having the derivation for this combination. In that case, we need a generalized error coefficient and generalized error expression. you need generalized steady state error expression. That's why this is required. Generalized error coefficients or dynamic error coefficients.